Well, hello and welcome to this short tutorial on how to make the power lids for the AWSOM units. Now, they're the electronics. We won't bother with those at the moment. This is the unit we're going to make today. It is thermally lined with the solar cells in parallel coming out to a connector which goes into that socket there. I cut one in half, and you can see how the units fit in that groove. We'll put a rubber seal in that groove before it's obviously shipped, but that's how the unit fits in. Right, so there has to be clearance for that unit on the board, on the variable board or the PCB, whatever board it is. The lining is 4 millimeters thick. This gives us about 3 hours delay in the temperature rise inside the unit, kind of heat shield. These are the solar cells, 60 by 90, and this is what we're going to make the power lid out of. Okay, the first thing we do is to make a template of the lid, or the size of the lid, and then we mark where the solar cells will fit. Make sure that they're nice and equidistant from everything, basically. Once we're happy that they're equidistant, they're orthogonal because if the spout shadow goes like that, for example, this cell here will not produce any power at all because all photovoltaics there won't produce any voltage at that, therefore they're all in series, so that's high resistance. However, as it's across the shadows across all these cells, then there will be lower current. They'll still produce voltage, but there'll be lower current, so that's why it will still work. And we can't put them this way around because the coefficient of expansion of these units is 0.404 inches per degree Fahrenheit, which is almost similar to the ABS, but not the same. So what happens when it gets really hot, these expand slightly because they get very hot, and they push each other out of the way, and basically they come off. So you have to have more distance between them. Now we did do it this way, but once again, if the shadow goes across there, you get no input. So that's what we used to do, but now the new improved version is put it around. So once we get a template, we pencil the size of the solar cells, and then we mark off which size is positive, and then we mark the slot that we're going to cut into the unit. Now this is the old one that I cut in half. This is the slots that we've put in, and then the solar cells will go that way. Right. Also we have to make sure it's very, very well sanded down all over. Sand it down all over. Do not touch the base, the lid, once it's been sanded, because your finger grease will make the solar cells come loose. So it has to be ultra grease free. So sand it down all over, make it abrasive. Similar with this, as soon as you touch this, you have to degrease it, lightly sand it down, because this is a backing. You don't want to just lightly abrade it, and then if you can get some isopropyl alcohol to make sure it's clean, and then you have to get some adhesive. Now this is the best adhesive that we found. It's not cheap, but it's the best adhesive. You can use other form of welding mechanism, but this is the best we've come across. We've used aldite, but it's not. Yeah, this is the best we've come across. Right, now I'm going to drill the holes and attach the solar cells using this adhesive. Right, cheers. Oh, by the way, that adhesive mustn't be stored below +8 degrees centigrade because it doesn't work too well. Okay, now and it's -2, so we've got to keep it relatively warm. Now we have the cells with adhesive on. We've also put a diode in series with the cells output on both of them, and taken the wires out to a connector. So we put a diode on the plus side, and you can just about see, well, that's minus, so you can see that's minus, plus side. And let's zoom in a bit here. So that's the line on the diode. The non-line goes to soldered into the positive side, and then that comes out on the positive, and that goes all the way around to here. This is the other solar cell, and the line, the white line on the diode, comes out here, and that's joined up to the positive wire, and then that comes out to the positive side of the connector, and it's that goes in the solar cell socket. Now, one thing you've got to be careful of is that these lids, as you can see, they are not flat, so you've got to be really careful and make sure that glue is really well stuck down. This is sanded down and cleaned down. Also, they have an injection molding point at the top, which really should be you should get rid of. Let's get on to the thermal heat shield. Okay, once we've made the template for the lid, the insulation material of the lid, we then cut it out of the heat insulation thermal lining, and make sure that it's glued in. I used Gorilla Glue with a little bit of spray water, because it is non-absorbent surfaces. Now what I've just done is I have just sanded down these surfaces here, in here, all the way around. Now they are slightly bigger than the width, because the edges can go behind the pillars there. Not a lot, because there's going to be 4mm thick insulation, and this is only about 1mm, so just a little bit. Similarly with the edge here, that can go in comme ça. Now we want to make sure that this is visible when it's sat down onto this heat insulation material on the lid. The reason is because this is elevated slightly above the base, and so that is the base, so that comes up there. So basically, anyway, you get the idea. Don't do it like that. Make sure it's a couple of mil free. Right, what you do is a little bit of a spray, like that. It's about 1 centigrade here, so I should have put that in my pocket for a few hours. Right, that'll do, I think. Let's go. Oh, this glue is too cold. Really having to squeeze quite hard on the bottle, which is not good. Okay. That'll do. I think. And push it down into the corner, into the corners there. Try and make sure that that is visible. That little bit of corner there is visible all the way around. Okay. So there we have the final power lid with the two orthogonal 6-volt 60 by 90 millimeter solar cells, which are remarkably resilient, by the way, on the ABS IP65 frame lid with the 4 millimeter thermal insulation, which is used for lining, putting on walls in houses, so you can get a lot of it for not a lot. Putting it all the way around, I've got the cable coming out here, which is a risk. Fine, yes, but and we've got a little bit of that serration visible, so that this will go sink into the framework there, and should give us that 2 or 3 hour delay of getting peak temperatures in here. Also, I have put a circuit diagram in there just in case out in the field people want to know it. It's there. It's not secret. It's been developed over a few years and it's proven to work. The last thing, oh yes, make sure that the positive of this is there. It's the top of the plug, with a plug facing that way, so that will go into the unit like that, and this is the battery that goes the same way. So the positive is the top wire, both cases. I will paint these so they don't accidentally go into the wrong hole. Oh, and finally, you really should try and put a label on it. We'll put a serial number on there. It doesn't last very long in the ultraviolet heat and water, but we try and make an indent, and so we can uniquely identify them all. I use the same adhesive to put that on, although I think I could have got away with Gorilla Glue on this. It's not really highly stressed, it's just these that are. That's it. Oh, this was put by Gorilla Glue in there, Gorilla Glue there, and a little fillet of Gorilla Glue all the way around. C'est la vie. Okay, cheers then. That's the power lid, and the best of luck making it. Bye bye.